Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We stopped yesterday after rewriting a bunch of stuff and we need to go debug it and get it working. Kind of a nice thing, actually. It's a lot like, I know that writers or writing teachers or something, I don't know, often say stuff like, when you're writing a book or something, stop when you know exactly what you're going to write next that night so that in the morning it's easier to get started again or something like this. I have no idea. Point being, we're in a situation where we know exactly what we need to do and it's just debugging work, so hopefully we can just jump right in. Day 316, you want to start with day 315 source code. That's what I'm working with right now. Hopefully you have that same day 315 source to start with. This is what was happening to us. Speaking of assertions on the pre-stream, this is exactly an example of one of those assertions. This is telling us that we have output a clip-rect index that is totally bogus. And so we need to kind of go look at all the sort of changes that we made to our code. And, you know, it's not really a surprise that we messed something up. It's kind of finicky code that we were working on. So we need to kind of go back there and just take a look at what's going on and try to make sure that we have our code nailed down. All right, so the first thing that I want to check, obviously, is, you know, we come in here and we get a clip-rect index that's way out of bounds, right? 16,527, not a clip-rect that probably means anything. I wanted to see what the header is here. It looks to me like the header is garbage, right? And the reason I just wanted to check that is because I wanted to know whether we were in a circumstance where, you know, we were looking at a wrong location, or whether it was a wrong clip-rect index. And it looks like we're looking at a wrong location. Now, I kind of already have, because, you know, we wrote the code hastily yesterday, and we didn't have a chance to really look at it at all. So, you know, in my mind, I've already got a bunch of ideas of probably what's wrong. And so I'm just going to go look at those first before I do anything more sophisticated than that. And the first thing that I want to look at is when we push it on, I don't know if I ever updated the code that actually sets what the offset actually is, right? And so if we look, when we do push render element, and, you know, we work with the offsets and stuff like that, you can see here we do, you know, whatever it is we're going to do. And we come down here and we take a look at the offset stuff. I don't know if this offset stuff is really what I want it to be. I don't really know. I didn't really look too carefully at that code, so I don't know whether those offsets are valid offsets or whether, you know, what they are or what's going on, right? So we kind of need to do a little bit of work to make sure that what we're doing here makes sense. And if I take a look at this code, it already looks stupid to me. I think I was probably just hallucinating when I wrote it. If you look at what's going on, that offset is supposed to be where in the buffer we wrote the data, right? And we didn't, like, what I did is basically compute how far there is to the end of the buffer, because I was thinking in end of buffer mode. But we don't want that. We just want to know where in the buffer it actually is, and so you can kind of see here that that's what this computation would have been. So that was just dumb, so that's the problem to begin with. So let's start, oops, I didn't load my proj file, did I? There we go. Let's start with that because that's at least one problem. Let's get that out of the way. All right, so now we're back to, looks like actually a saner situation. Let's see how we're doing on the rest of our sorting. So that actually looks like we're sorting properly now in terms of our slices. So who knows, maybe that was the only error, I'm not entirely sure. But we definitely have one other problem that you can see that we've introduced, which is previously we sort of had this thing for sorting the hero structure, and you can see that that's all busted now, right? You can see that the hero is not at all, that aggregate sort concept that we had there, that's obviously completely trashed. So we need to kind of go fix that. And we also have some weird things here, like what's going on with those trees and stuff like that. So we've got a bunch of things that we need to go look at, and so we can go look at them now. All right. So the first thing that I want to look at is actually, I'm going to take a quick detour here because I want to sort of take it one thing at a time. inside Handmade world mode, when we do add standard rooms, I'm going to go back to just one room briefly, and I want to take a look at the aggregate sorting, since that was code that we kind of broke before. So you can kind of see, and you can see there's more than just that that's wrong, right? Because if you look at what we had before, we didn't have all those weird blinking tree problems, right? So we're not quite there yet. We still have some errors as to what's happening. So let's take a look at what's going on there, and let's start to try and solidify that a little bit more. So one thing that's true about this is I do want to make sure that this offset is actually correct now. We know that it's not woefully correct. It's not crashingly wrong, but we don't know if it maybe points at slightly the wrong thing or something like this. So if I have my push buffer data at and my push buffer base, and I subtract those two, what I want to know is this actually pointing at the correct location? I think that it is, but let me just make sure of that. So in here, we have the... In fact, you know what? Now that I think about it, what we really want to do is say where the header actually is, right? That's what we're trying to point at anyway. So let me just do this. I mean, that's what we actually wanted. Now, I think those are the same thing. So this shouldn't change anything. We should see the same behavior. But that's what I want to start with, certainly, right? And so that's the baseline. So now that I know that I've got that offset pointing at least the header that I'm actually filling in, right? And you can see that I'm filling in sort of the various fields of that, and then I'm filling in the sort stuff as well. What I want to do now is take a look at the group is aggregating. And so for the group is aggregating stuff, and I say first aggregate at, we have the sort entry count here, and I'm just saying if this happens to be the first one, then I'm going to copy in the sort key, and if not, then I'm going to do the merge operations, right? I'm going to do a merge operations with that same sort key that we were passed in. So what I want to know is this operating properly? And I just want to take a quick look at the actual code for this. So when we do a begin aggregate sort tree, we're basically saying that the first aggregate is at wherever the sort entry count was. That's what we're saying, right? And that seems correct to me because that's pointing at essentially the next one that we're going to fill in. So then when we come here and we say first aggregate at equals commands sort entry count, I'm not really sure that makes the most sense. I mean, really what we want to do is take a look at whether it equals this thing. So I feel like the safer thing to do, rather than trying to be math tricky about it, is I could just say first aggregate at equals push sort entry and just actually take the get sprite bound, right? The what is that called? The get sort entries. That. What I could just say is, well, if I was going to do get sort entries plus first aggregate at, I would want to make it be push sort entry. Now, the thing that occurs to me about that is I'm not sure why we're actually using an index for that in the first place. Like, do we actually need an index, or can we just use a pointer? Because if you look here, when we do our iteration, it's like we're doing all this work bending over backwards to keep it an index. I say we just change it to a pointer. While I'm debugging this, I might as well change it to something that I want it to be. That way I'm not debugging something that's not what I actually wanted, right? So let's go ahead and set sort sprite bound to be first aggregate like that. And then what I'll do is say, okay, when we do first aggregate, we could also get rid of this is aggregating flag too if we wanted to. Actually, we could just do this first aggregate and get rid of this aggregating. So then what we could say is just like, okay, let's assert that there isn't a first aggregate. When we come through here, we'll set the first aggregate to get sprite bounds. Sorry, get sort entries. I'm never going to get that right. Plus sort entry count. So whatever the first aggregate is whatever the current one is. And then we'll save that. Then here we'll assert that we've got one of those. And at the end, we'll just set it to nothing. That way we don't need an is aggregating flag anymore. So then when we come through here, we can say instead, let's just snap a pointer to the last one. So this is like one past last entry. And that can just be whatever the current sort entry count is now. We know that's the one we're going to stop at. So then we just say, all right, we've got a sort sprite bounds. We're going to start it at whatever the first aggregate was. Render group first aggregate. We're going to go for each entry until we get to the one that we don't want to process, like the very last one. And then we're going to plus entry. And you can see that was a minus entry. That was wrong already. So that was a bug as well that I just fixed. Because we're going forwards now, not backwards. Right? So then we come through here and we say, OK, do the operation we're going to do, and then clear it out. So that seems a lot more sane to me. And then up here, all we have to do now is say, well, OK, if the first aggregate that we're working with is the one that we're talking about here, then we finish it off, right? So that seems totally sane to me. That cleans that up to I think a better place than it was before. And so I'm hoping that we can make that work cleanly. Now, last thing is that now, since we've reversed the order, I think we can go back to standard order on the other things that we pushed, because before we had actually done them in like sort of reverse wise, if that makes sense, specifically so that we wouldn't have to worry about the fact that they were reversed before. So in add, player or whatever, we had actually reversed this order to cape, torso, shadow instead of the other way around. And so now we can kind of go back to logical order where we're pushing the order we're going to draw, which I like better. Like, I'm glad we could do that. And now I think we're good to go, right? So now we just have to fix the head. I believe the head is still wrong. Let me check. Here, familiar, can you block me for a second? Thank you. Yeah, so I feel like that is, the head part is still kind of wrong there. Yeah, and I'm not sure. Where exactly that's coming from. So I want to take a look at that one as well. Okay. So in Handmade Render Group, I'm pretty sure reserve sort key really has nothing to do with that stuff we changed. So I'm not sure why that would be the case. What I could do actually as well, and let me just go ahead and change this now that I think about it. So inside platform, I'm going to turn on the drawing here. I want to see whether we're getting a cycle at that point. So we are getting a cycle when that happens. So I suppose that it's possible that it's just because, again, we're not really breaking cycles in an intelligent way. Let me double check that I can't make it happen without a cycle. It does seem, it sure does seem. So it will sometimes work when there's a cycle, but of course that's expected because we break cycles randomly at the moment. But it doesn't seem to break unless there's a cycle so far. So that may actually just be because of cycles. Hard to say. Yeah, so that may just be because of cycles. We'll have to think about how we should break cycles, because I'm not really sure what the way is that we would want to break them. I haven't really given it much thought, so I'm not sure, but yeah. All right, so that's our current situation. Let's go ahead and crank back up the room count and start to look at some of the other bugs again, because that just seems like a good idea. You know what I'm saying? So add standard room. Let's take a look. Add standard, no room. Like, how many rooms? I don't know. Maybe 4 is fine, let's say. Okay, so we're not getting a lot of those other bugs at the moment, so it looks like we fixed a bunch of those with the way that we were. So those blinking tree bugs were probably mostly based on the fact that we were going backwards in the order. We were probably overwriting sort keys for other entities. I wouldn't be surprised if that was the case. So let's take a look here at how that sorting is doing. It's looking pretty good, I guess I would say. So that's good. And yeah, everything looks actually relatively solid right now. So that's starting to look pretty respectable. And I think, you know, we've got more stuff to do here, but it looks like the sort is less of a concern now. The cycle breaking is going to be something we're going to have to deal with for sure. We'll see what happens when we put stuff in that has the correct bounds as well. But that's starting to look pretty reasonable. So I think now we can go back to what we were doing before, which is getting the layer stuff working. Because that seems okay. All right. So yeah, and now, you know, in theory, at least anyway, we're sorting by group now, so we shouldn't have, hopefully, as much pressure either on the sort. And let's take a look at what's going on there. So if we take a look at build sprite graph, we're calling it four times, but it is taking up a tremendous amount of time there. Although, you know, one thing that's a little bit hard about that, we don't really want to look at it in the context of the debug system. So let's just go ahead and quickly pause and then look back at some of these. Okay. So if you look back at what's happening when we don't have the debug system up, so here's a frame that doesn't have the debug system up and visible, you can see that it's kind of quite a bit less. Then once the debug system is visible, it's giant, and that's because all of these sprites are all getting sorted as well. And you can still see that get close is traversable is one of our worst offenders as well, which is good because that's a completely unaccelerated n-squared algorithm, which we know how to trivially accelerate, so that's a good one too. But that's still a lot of time spent in build sprite graph. Again, periodically I just kind of like to check to see what the situation is here. So I'm just going to check build.bat really quickly. I want to see what happens in release mode and make sure that there's nothing particularly unusual going on there. Let's just take a quick look at what's happening there. Here's the profile. And, you know, we can kind of see that in this situation, build sprite graph it's still expensive, but not too bad. And if I go back to look at some other frames here, so here's one where the debug system isn't up. 3% of the time isn't bad, you know? Do I love 3% of the time? No. But, you know, that's really not that bad considering how much work it has to do. And, you know, we haven't done a whole lot to optimize it yet other than just the grid-based stuff. So I'm okay with that. That's not going to make me too nervous, not going to lose sleep over that guy. So I think we're okay, right? And this is nice and zippy. This is 60 frames a second as well. Let me unpause this guy. There we go. So yeah, so this is running at 60 frames a second, so we don't really have to worry too much at that point because, yeah, I mean, the actual game itself isn't going to be that much more complicated in terms of what's happening on the screen than what we see right here. You know, so because this isn't a game with like thousands and thousands of sprites that's supposed to be, you know, roughly how many there are on the screen right now. You know, there'll be more effects happening, but effects can kind of be their own thing, I think, a lot of the time, hopefully. So yeah. All right. So that all seems good. I don't really have any problem with that. I think that's all pretty reasonable. So now what we kind of have to look at is sort of what I was talking about before of we have a problem at the moment as far as alpha blending in, and let me see if I can get it to a point where it's actually happening. In order to do that, I'll have to go downstairs, won't I? Okay. So this is an example of the alpha in problem, but I unfortunately I don't have trees that are quite on top of each other enough. But you could probably kind of see it happening down here a little bit. And that is essentially that, well, you know, if we were to stack up some stuff, let me see if I can actually get that happening somewhere. So I'm just not sure how to get anything all that more obvious. I mean, on the one hand, maybe it's a waste of our time to even go down this route, but it would be nice to show. I guess one thing I could do is if I made this red, that might help. So I'm going to go ahead and do that. So let's suppose we went into the world mode code, or actually I guess that's an entity now. When we draw the traversables, we do an occupier check, and if someone's on an occupied square, we change the color. So what I'm going to do is I'm going to change that to pure red. And so here you can sort of see that happening, right? So now what I'm going to do is I'm going to kind of come up here. So what I want you to focus on is this is the area where this familiar's head is floating, right? You can kind of see it. Now there's no red there. It's like brown, tan, or whatever, right? But doesn't look red. Now as soon as I go like this, you'll notice it becomes kind of almost a reddish shade, right? You start to see red in there. It's all kind of almost more of a uniform color, right? And that's because this is getting transparent, if that makes sense. You can start to see that getting transparent. Now for a more, I can do an even more obtuse or obvious version of that, probably. Let me see here. If I was to say shrink how big these are, so suppose I was to set this to something thin. So do you see how this is probably the most, yeah, I should have thought this before. So do you see how you can't see this line coming through the head, right? You know, the head's opaque, it completely blocks out what's behind it. But when I start to alpha it out, all of a sudden you can see through the head. But you're never supposed to see through the head. We're supposed to alpha out that whole floor as one coherent piece, right? And so that's a good example. That's probably the best example I can give of why we would want to alpha out everything and so that it doesn't look like things are disappearing. It looks like the whole thing is fading away rather than pieces disappearing on top of other pieces which are also disappearing independently, if that makes sense. So hopefully that's a little bit clearer what's going on there. I don't know, hopefully you can gain some sort of appreciation for why I might care about that, being sort of a person who's OCD for that sort of thing. All right, so let's go ahead and take a look at what it will require to make that happen. Now we already have the concept of a barrier in here now, right? And so we know that when we go to render things, we have the ability to have things occur at barriers. So if we take a look at what's happening inside our sort code, render, there we go. When we come out of here, when we come out of sort entries, this sorted list of indices, what it has in there, obviously, are the things that it has in there can include information to the render system about stuff that needs to happen. So what we want to do there, potentially, is have there be a way that we can insert something in addition to our barrier that says, like, hey, we need you to do an alpha fade on this whole thing that's coming up next. So you have to kind of do a separate composite to it That's just kind of the way it goes, right? Now, I don't know that that's... I think that might be pushing the system a little bit too far at that point. And so what I think we're going to probably want to do at this point is to actually have the notion of a coherent block that has render that knows how to do some kind of certain rendering operations, right? So I think what we want to do is have our render command list actually have some understanding of sort of what's in there, and we probably don't want to do something quite like that. I mean, maybe we do, I don't know. I mean, maybe this is a fine architecture for it, considering that we don't really need to push it that far. But yeah, I don't know. We'll see. Maybe it's fine to have those in there. Maybe it's not. I'm not entirely sure. We'll see as we go. But for the time being, we kind of have to ping pong back to our OpenGL code and our other render code in order to make this stuff work. So the first thing I wanted to do, though, is I want to see if we're still rendering okay through our other system. And it looks like we are. So this is the software renderer. That's so cool. I love the fact that our software renderer is so accurate. I want to fix that half pixel offset as well so that they're just exact. Someday we got to go do that. So anyway, here is the software renderer doing its thing and looking awesome and all that. So what I think we want to do is go to our software renderer and implement this first so that everyone understands what it is that we're actually doing. And then we can go back and implement it in OpenGL, which is, as always, a huge pain in the butt because OpenGL and basically all graphics APIs are ridiculous. So let's go ahead and talk about what needs to happen in order for that to occur, and then we'll get started on it. Oops. So what we are going to be talking about here is multiple render targets. And the phrase render target basically means, buffer of memory that you draw to. So what you have seen throughout the course of Handmade Hero, when we wrote all the software renderer and all that stuff, you'll note that we were always rendering to the same piece of memory, right? We had this notion that there was sort of a back buffer, like a screen buffer, that was holding what we were going to display. We render everything into it, so that piece of memory we draw into. And then when we were done, we basically handed that buffer to Windows and said, here, show this. And then when we did the OpenGL version of the code, we did essentially the same thing. We just said, here's all the stuff we wanted to draw into that buffer, and then when we were done, we said swap, like show it to the user. So that's how we've been thinking about things, right? We've been thinking about things in the sense of here is like the screen, and we've been thinking about like all of this stuff kind of like being drawn onto it, right? And then we display it. So it's really like a back, we were sort of thinking of it as like the back screen, and then we were bringing it forwards, right? Well, what we have now is the need to expand that notion. So what we want to do now, right, is we have the actual screen, and previously we had, one buffer. We called that the back buffer, but let's call it, now that we're sort of spinning out, let's call this buffer A, right? And previously what was happening is we did all of our drawing into buffer A, and then we had some way of getting buffer A to the screen, right? That was either via a call to Windows that says, here, take this buffer and show it on the screen, or a call to OpenGL that said, we're done rendering now, show the buffer that we've been working on, okay? And so previously, that's all our sort of composite phase looked like. But what we want to do now is we essentially want to take two buffers, right, or more. So we want like a buffer A and a buffer B, and we want to combine buffer A and buffer B and draw them to the screen, right? So what we want to do is we want to draw a bunch of stuff into buffer B, we want to draw a bunch of stuff into buffer A, and then we want to combine them using a standard alpha operation, right? A standard alpha blending operation, like what we've been using, that sort of composites those two things together to produce our final screen. And again, the reason we want to do that is so that we can apply a uniform alpha fade to this buffer, or, well, we can choose whichever buffer we want to be the one that we're fading in and out, without having separate pieces become like see-through. Hopefully that makes sense. So that's what we need to do. And so if you take a look at the way that our old renderer, our software renderer worked, you know, we can sort of pull that back. And you can see that the way that that was happening, if we go to software render commands, is we pass it in this output target, and the output target's the thing that was sort of doing double duty, right? Like I said, it was basically buffer A and the sort of back buffer. It was basically just, we didn't really distinguish as to what it was. So it's just a place that we drew our stuff to, and then it was going to get displayed. But what we want to do now is essentially have more than one of these output targets that we choose between, and at the end we'll composite between them, right? That's what we actually want to do. Now, we have a situation here where I thought when we passed, I'm going to verify this, I thought when we pass these in, yeah, so we pass in a temp arena to prep for render. I'm gonna keep that love going. So I'm gonna say that software render commands gets a temp arena, the arena for doing allocations, right? So where's that prep temp arena? There it is. So that way we can have some scratch memory, right? So I'm going to start really, really basic just so everyone can follow along with what I'm doing. All I'm going to do is I'm going to introduce a totally extraneous, completely unnecessary piece of work that we're going to do just to show you what I mean. So right now we have a loaded bitmap. It's called output target. We know that whatever we draw into output target is what we were then going to hand to Windows in the software interface and say, here, display this in your Windows system. We don't know, we didn't write Windows, we don't know how you're going to do that. We just know we produced a beautiful looking game image for you. Please display it, right? So that's what output target is. And if you remember what that actually looks like, I can't remember where we define loaded bitmap. I think it may be in the render group code, loaded bitmap, or it may have been in the asset code. I never remember. There it is. So we have this loaded bitmap, and we've got that sort of memory pointer and all that nonsense, right? And so if we wanted to, what we could do is create a separate one of these loaded bitmaps that we draw to instead. Because remember, output target is just something that we pass through here. You can see all of this stuff where we do software render commands. You can see us doing this sort of work with the output target, right? And then when we have all that stuff, it actually kicks off the work and all that, you know, blah, 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 right? So software render commands, when it gets called, that's what it's going to do. And so if I wanted to, I could say, call this final output target. I could, if I wanted to, create another exact copy of it, right? I could basically say, let's say we have another output target, which is going to be like a push struct on the temp arena. So it's going to create another one. I'm going to copy all of the values of the final output target, right? So basically all this stuff, the width over height, the width, the height, the pitch, all that junk, we're going to copy exactly. But since there's two different, you know, we don't want it to draw to the same memory, although, you know what, I could. I just leave, even if I leave the memory pointer the same, now if I just am using that one, nothing would change, right? I'm just going to do the same exact drawing that I was. Of course, I want to set it to actually call that renderer, so I don't have to switch it every time. So let's go ahead and say Win32 rendering type equals Win32 display OpenGL, but render in software, so that now we'll be rendering through the software renderer at startup by default, and there we go. So, it's just doing the exact same rendering, and it's using the exact same memory pointer, right? But now I'm going to change it to say, okay, now I want the output target's memory. I would like to have a memory block that's the same size, right, as the other memory block, as the one that was getting passed into me for the final output target, right? So instead, I'm going to now go to loaded bitmap. Where is loaded bitmap? And look at it, right? So now I want to say, well, okay, I'm going to set the pitch to whatever I want the pitch to be. So I'm going to set the pitch to be the width times 4 because I want it packed. So I'm just going to say, like, okay, the output target. Oh, well, actually, you know what? I'll leave the pitch as it is. I'm going to assert temporarily that the pitch is positive. Is that true? Yeah. So I'm going to assert that the pitch is positive, and then I'm just going to say, okay, the memory block that we're going to render to now, I'm going to push basically a block of memory on here that happens to be exactly as big as I wanted it to be, right? I want the pitch times the height, so a block of memory that's basically as big as the old one was, and I want you to give me that spare block of memory, and that's what we're going to draw to now. Now, we know that this stuff has to be aligned, so I'm going to go ahead and ask for alignment here as well. I'm going to look just to make sure, because I'm pretty sure that we asked for the alignment in the existing one as well. Yeah, you can see here, this is how we did this stuff. Oh, we virtual alloced that. Wow, aren't we fancy? My goodness. Well, okay, that's not how we're going to do it here, but whatever. So let's go back to handmade.h. Is it memory? That is it. There we go. I just wanted to look at how I did alignment there, and it looks like align no clear is what I probably want to do. So I'm going to say align no clear, and I want you to align to 16-byte boundaries, so it's SSE aligned, right? So now I believe I can just run it, and what we're doing now is we're rendering into that block of memory. Now you'll note you don't see anything on the screen, and the reason you don't see anything on the screen is because we didn't touch the actual buffer that we're displaying. But we didn't crash because we gave it a completely new buffer that can handle it, and so it's fine. So now what I want to do is when we get to the end, I want to copy these two. So after we do complete all work, I want to do a thing where we basically say, like, okay, let's loop through all of the pixels and actually copy them one by one. Now, I suppose I could just copy the whole memory. I could just do this. So maybe that's the easiest thing to do first. And that's, again, pretty trivial. All I'd be doing there is saying, well, I would like to copy the output target's pitch times the output target's height, worth of memory. I'd like to copy it from the output target's memory into the final output target's memory. Right? And there we go. So now we have made our renderer slower, certainly, because it's doing a big old copy of the entire screen for no reason, but we're seeing what's happening, right? We're seeing what happens to that back buffer. So now we've created a situation where we are doing this. We are basically saying, okay, renderer, render into output target. We are then issuing a copy to final output target, right? And then we're taking that buffer and we're giving that buffer to Windows. And that's what we're seeing on the screen for the software renderer side of things, right? Okay, so hopefully now you can see it's a pretty short step to do two different renders, right? If I want to, I just now need to know what are the two things that I'm going to render, right? I just need the ability to shunt things into different render targets. Now, since we already have the concept of clip recs, it seems to me like it would be pretty straightforward to do the same thing for render targets, right? So when you specify clip rect, you can also specify what render target you were looking at, right? Now, this is not the kind of clip rect I'm actually talking about here. This is the clip rect, obviously, for the tile. I'm talking about the other clip recs that are specified in the actual stream. So, all we really need to add to the render system, other than some kind of an index in the clip rec that says which render target to render to, is we need some way of saying how the final composite stage works, right? That's what we need, something along those lines. And in order to do that, there's a couple of different things we could do. One of them is to just actually include those things in the stream. And that does seem like kind of a compelling way to do it in my mind. So I think that might be the way I would like to do it. And furthermore, because we have this concept of sort of being able to render to, we could probably do something where we could select these as sources as well, I think. It seems likely, right? So let's take a look at what it would take. We'll take this one step at a time. I don't have very much time left, unfortunately, but we've got about 15 minutes. We'll make the most of it. So let's start by going into the render group code. And inside the render group code, I want to sort of do exactly what I was doing with the clip rect index stuff before. Instead of just specifying a rectangle 2i, I want to specify a render target as well. So in here, I'm going to have like a target index, something like that, right? And that target index would allow me to say that I have more than one render target or who knows what, right? And again, I'm gonna, I'm not gonna implement a really particularly robust system for this. I'm just gonna do a very basic one. But this would basically say, okay, for every clip rect, I'm going to have a target. That target is going to tell me where I'm going to render to, and I can now have more than one render target in play. So what I want to do there is I want to say, probably in the object transform, I'm guessing, but let's see, clip rect index, current clip rect index. So in here I could just say current render target index, I suppose. Well, actually, when we push the clip rect, that's when we would do it. Push clip rect, right? So here in the clip rect, when we specify one of these clip recs, presumably what we would do is say, whatever the render target is that you say that you're going to render to, that would get set here. So in addition to that stuff, you would say, render target index, something like that. And the render target index would just be like, okay, here when we set the rect stuff, that gets recorded, right? What did I do? What did I do? I just called it target index. There we go. Oops. And so now when we're actually putting clip recs in here, I should, okay, I should be able to specify multiple render targets. They just won't do anything, but I can specify them, right? Like so. And so by default, obviously, we'd always render to render target 0. And when I do push clip rects, we've got a couple of different times that happens here, mostly in the debug system at the moment, right? And those I think we don't really care too much about. But what I'll do here is say, render target or something like that. So, we can set it to whatever we want it to be later if we want to have a separate render target for the debug system, right? And so in that case, I just need to store that here in the debug state. So I would have something in here where we're like render target, and that would just get cleared to 0, presumably whenever everything else gets cleared to 0. And then we should be done, right? That's all that would have to happen to have that be specified. So no big mystery there, nothing particularly exciting. Now, what we do need to do, however, is in the render group, when we actually do set that information, so when we do a push clip rect here and we actually set that information, what we need to do is make sure that if the group commands render target count, which is something we'll have to track, is not sufficient. So if it's less than or equal to the render target index, or I guess we'll call it max render target index, if those are insufficient, then we will set it. So this way we'll track whatever the maximum render target index is that you used, we will remember it, right? Okay, so let's see, clip rect count. So in here, with all the rest of this stuff, which gets initialized, we can just say max render target index, like so. And that should now always be set to whatever that value, whatever the highest one is that we actually used. So now what we can do is go back to our renderer, right? And make essentially a table for the renderer of the render targets that we needed. So here we are in there when we do software render commands. What I'm going to do now is I'm effectively going to clone out as many render buffers as I think we need based on that number. Okay? So what I'm going to say is render targets, right? Like so. I'm going to do a push array. And I'm going to say I want a loaded bitmap render target for you know, it's kind of amusing. We used the same thing for loaded bitmaps as if for drawing, but I don't really remember why we ever did that. Did we ever draw to something and then use it as a texture? We did. I know what we were using that for. Yeah, we used that for ground chunks. I was like, I knew we must have done it for something. That's what we did it for. All right, so anyway, I'm going to push an array of these guys, and I'm going to push an array of max render target index plus 1, right? So that way, and in fact, I'll just do render target count here. I'll just sort of compute that up above so we can see what it is, but there you go. So I'm going to create an array of those, and I'm going to set the first one equal to the final output target, right? So render target 0 is always just the screen. And then I'm going to do a loop over all the other ones, if there are any, right? So, you know, I'm going to go from 1 to the render target count. I'm going to go through each of the targets, and then I'm going to, well, I'm going to still do this part here. I'm going to get a chunk of memory for each of them. So for each case, I'm going to go ahead and say target equals render targets plus target index. I'm going to just romp over everything with whatever the final output target settings are, and I'm just going to give it new memory. Everything else will remain exactly the same. Like so. And then in here, so for the tiling, 5-minute warning. For the tiling, I'm going to do the same thing, right? I'm just going to use the final output target for it instead. And then all I really need to do for these output target things here is instead of that work that sort of work array. I don't know where that's actually defined, to be honest with you. What is that called? Tile render work? Where's tile render work? There it is. For tile render work, instead of output target, I'm going to call this render targets, like so. And I am going to set that to our render targets array. So now there's like, n render targets, and you can render to any of them that you want. And so then what we will find is out here where we do this, let's see, what is this doing? Render commands to bitmap. Yeah. So when we do render commands to bitmap, instead of this output target thing now, we actually need sort of a render targets array there. And that's a nice old array. And we pass it. And let's see who else needs that, because there's some other people who apparently need that. Let's find out who that is. So render commands bitmap, draw rectangle. That's the clear. Let's see here. Output target. Those are all output targets. Here we go. Final output target. This is all final output target. Oops. Okay. So yeah. This no longer needs to be here. And so I think that's basically it. All we now have to do is select the actual output target that we want from our cliprect. So we have a loaded bitmap. It's our output target. It's going to be render targets plus whatever the cliprect is that we're currently using. So I guess I can do it like this. It's going to be whatever the cliprect is that we're currently using, plus, I'm sorry, it's going to be the base of the render target array, plus whichever cliprect entry we're using, whichever render target it says that is. It says it wants. Okay. So... here we go. And done. So now everything is doing exactly what we want. In theory, we now have multiple render targets. We don't composite those render targets, but let's just check to see if that's actually working now, right? And we can do that pretty easily, I think, just by saying, let's take the debug system, and let's set the debug system so that its code is not going to use the default render target, right? So when we call debug begin here and we set default cliprect to be current cliprect index or whatever this is, I think this is using a custom cliprect. Let's go ahead and set that custom cliprect because we know we have that in here, render target. I think that's what it's called. Yeah, render target. Let's set render target equal to 1. So it's using a different render target number, right? Poof. Where did it go? It's getting rendered to the other render target. And we can't see it, which is exactly what we expect and exactly what we want. So now we have more than one render target in the actual software renderer. We just don't have any way to actually say how we want those things to be composited. But that's okay. That's something that we can do next week. So I will go ahead and leave that in this state. Let's go ahead and go to the Q&A. Oh, I'm sorry. I didn't mean to say next week. I meant tomorrow. A bit unrelated to the project, but what do you think about the Rust language? Yeah, that is a bit unrelated to the project, considering the fact that it is not written in Rust. I have not used it, so I don't have any opinions about it. Build strong. So when do we think we'll be ready for the new graphics assets? I'm excited. When we have Z solidly under control, and we might want to do lighting as well. So we kind of have a couple things we got to do there, graphics wise. And that's about it. So yeah, probably should stop doing that. But can you explain what this game is? Yes. Well, it's actually an educational programming series. The idea behind it is to show creating a game completely from start to finish, not using any libraries, or even we don't even require OpenGL or even hardware acceleration. Like we even, like I was just showing at the end of this stream, for example, we wrote our own rasterizer that actually draws all the pixels one by one, and so the game per se is basically a reason to show how all this stuff is done. And you know, eventually it will be just a game on its own that you can play and have fun with. But the point of the vast majority, certainly of all of the Twitch coding, is a little bit different. It's not to generate, you know, publicity for the game or something like that. We're not just showing like fun parts or simple things or whatever. We're actually just showing how to do game programming. And the goal of the series is to have a really complete sort of video series at the end where you can see how every last little part of a game is made, if that's something that you're interested in learning. And you can look at specific parts if you want to see how a particular part of a game can get made. That's one. Is writing to that other currently invisible render target much any less computationally expensive than also sending it to the display? Well, it's not probably that much more computationally expensive to render to the target. It can be. It depends on the cache situations and various other things, right? Because since we have a tiled renderer, if the tile sort of data stays in the cache, multiplying out how many of those tiles you have to have. I don't know to what extent that would cause problems. It depends how often you flip between rendering to the different targets as well. So there's a bunch of stuff like that that could be there. But in general, the main cost that we're adding isn't that, hopefully. The main cost we're adding is the composite step, because that's pure cost, right? So when we render 2 render targets, if we had rendered all those things to just 1 render target, is that a little faster? Yes. But is it hugely faster? Possibly not. What is going to be much slower is the fact that once we have multiple render targets, we got to bring them back together somehow. And so that's a bunch of extra bandwidth, right? A bunch of extra bandwidth, grabbing all that data back from the render targets, compositing it together, and putting it into yet another render target, right? So that's what I would say. With multiple render targets, are there other effects you can do other than the alpha blending? Well, you know, as far as multiple render targets is concerned specifically, you know, usually what you're talking about for render targets is if you want to do stuff like, I rendered the screen and then I like did some kind of a wipe or like a maquette, like, you know, maybe you've seen on old Nintendo games, like they do a circle that squishes into like, and then comes back out. You know, once you are rendering to separate targets, you can have mats between them, or you can offset them, or you can do stuff like that. So, you know, you can also take a rendering and put it somewhere in the game. So if you wanted like a little TV screen or something, you know, you could do stuff like that. We won't really be doing that stuff. There's nothing in particular that I have in mind that would require any of that. But, you know, you can easily think of a lot of reasons why once you have the game render into a buffer, things that you could do. Are you going to support shaders? And if so, will you try to support multiple render targets in the shaders? So no. So I'm not sure which question you're actually asking. We don't have any need for shaders themselves to have multiple render targets in the shader, because that's a real thing. A shader can actually target more than 1 render target at a time. However, for a game such as this one, that's a 2D game, that would be like a fantastically bad idea. And the reason for that is only some graphics cards can support multiple render targets out of a single shader. And since we don't need the extra performance the only reason you do that is if you have specific performance reasons why that's more efficient for you to do. We can easily just run the shader twice and run it to each target if that's something that we actually needed. Now, I don't even know that we have any reasons why we would even ever have a shader that would write to 2 targets at the same time anyway. I don't think we have any situations that would be like that. So I don't even think it would even come up. But point being, we wouldn't be doing that. Now, on the if what you were actually asking is just when we do the OpenGL version, will we support, because we have an OpenGL renderer running as well. When we ping pong over to that, will we add render target support to that? Yes, absolutely. But that doesn't have anything to do with shaders. Shaders don't even know that there's multiple render targets. They just know that they're like, until you actually start targeting more than 1 render target inside the actual shader, it doesn't even know, because that stuff gets set outside the shader before the shader gets invoked. Are you excited to get an ART64 toolchain up and running to get this thing to run on a Raspberry Pi 3? Not really. Platform work doesn't usually excite me that much, to be honest. I kind of wish we had just settled that matter from now and had just a chip. The day GPUs go away will be my happiest day of all times. But yeah. Lord Marshall, are you still working full time? Why only stream 1 hour a night? Yes, I work on an actual, like, full big game project in my normal hours of work. SE24VAD, how would you go about rendering huge tile maps? Some batching techniques or any tips? What is a huge tile map? I'm not sure what that means. The tile maps in Handmade Hero can be so large that you could never really even walk across them. So if the question is just how do you render a scene out of a giant tile map, we already do that. If the question is you want to zoom way out and have tiny little tiles, the answer there is, like, I'll be honest, chances are you won't even be able to get the tiles tiny enough that you even really care performance-wise. You just can't fit that many tiles on a screen. I mean, even if each tile was only 1 pixel big. So if what you wanted to do was zoom out to the point where each tile was a fraction of a pixel, or something like that, then you just need to have multi-resolution. You need to have knowledge of what, basically bitmaps of your world map, so you can say, okay, for this whole region, what's the tile that I should use, or what's the color that I should use? But I'm not sure which one you're asking. Buildy Strong, would that be a good technique to use to create an overhead map? Yeah, possibly. I mean, it could be. I don't think you'd really usually need to, though, because remember, you can just set a clip region and then render up into the corner a smaller version. You don't really need a separate render target for it. Separate render targets are only necessary when you actually need to combine two things after the fact using operations that could not have been done just in place, right? So alpha and other kinds of composites like that are good examples of that, right? Insobot is pretty great. I'm loving these Insobots. Let's see. All right. Let's go ahead and close down. Thank you, everyone, for joining me for Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, which I update nightly, so you can play around at home and learn. We have a forum site you can go to ask questions, a Patreon page if you'd like to support our video series, a schedule bot you can use if you want to have the schedule tweeted when we're going to be live, and also an episode guide if you're trying to catch up on past episodes. That's it for today. I will be back here tomorrow, I believe 8 p.m. Pacific Daylight Time, but check the tweet bot if you want to know for sure. Until then, have fun coding, and I will see you guys on the internet. Take it easy, everyone.